Welcome back to our 8th and the last video for Chapter 4, Effects of Electric Current. And today we will study the construction and working of an AC generator. I've already explained in the last video the difference between an AC and a DC generator. The only difference is the direction in which the current moves. In a DC generator, it moves only in one direction. For that we use split rings, so that the contacts are changed every time and the current goes only in one direction. But in AC current, we have alternating current, so the direction of the electric current changes after every half turn. We have also looked at this picture here, and we know that if we can make this shaft turn continuously in magnetic field, electricity will be generated even without using a battery. But we will require some other form of energy initially to make this coil rotate. So this rotating action is the mechanical energy which is getting converted into electrical energy, like we see here. So now we'll study the construction and working of AC generators. Generators use, as I told you, the movement of the shaft, the movement of the axle, converting mechanical energy into electrical energy. So the rotating coil, either we can make the coil rotate or magnet rotate. It's easier to make the coil rotate in magnetic field, and continuously rotating that coil in magnetic field will create electric current. To rotate that coil, we may use thermal, atomic, wind energy, etc. Now if we use a split ring, then we will have DC current generated, and if we use slip rings, we will have AC current generated. In India, the current that is generated at the power station normally are thermal power stations or wind power stations, and that is brought to our home is normally AC current. This ensures minimum power loss during the transmission. Direct current will have a lot of loss of energy, lot of loss of electric current, but in this case with AC alternating the direction every time, there will be minimum loss of electric current. So talking about the construction, if you look at the diagram, it looks almost similar to our DC motors. But what is missing in this generator is the electrical cell. We don't have a battery. We have a galvanometer here, which will show us that how much of current is generated and in which direction the current is flowing. Instead of a galvanometer, we can also put a bulb, which will keep on glowing. So this could be anything but not a battery. Then also, what is different here, instead of split rings, we have slip rings now, and one end of the coil, this is the same amateur coil, so we have a rectangular amateur loop or a coil, which also called as amateur or rotor, and having resistive coatings. This is placed in the same way in between the north pole and south pole of a magnet, in such a way that the arm A, B, C, D are perpendicular to the direction of the magnetic field. The arm AB is connected to one slip ring here. So it is connected to the slip ring, say R1, and the arm CD is individually and separately connected to the ring R2. These rings are tightly fixed on the axle. So as the axle is rotated, the ring along with it will also rotate, but they are loosely touching or just brushing against the brush. So R1 is brushing against the brush B1, and the ring 2 is just brushing against the brush B2. They're just brushing. So as it brushes or as it rotates, the contacts will not change. The contacts will always be the same. So at any point, the C and D part or C and D arm will always be attached to the ring 2 and brushing against the brush B2. On the other hand, AB will always at any point be attached to the ring R1 and brushing against B1. In no way will CD come to B1 and AB go to B2. So AB remains attached to B1, the brush 1, and attached in the sense brushing against it. So there is a contact with the entire ring. The brush is constantly making an entire. So as the brush is rotating, as the ring is rotating, the brush is all the time brushing against it. Okay, so that is what we need to note here in AC generator. Then the two slip rings are R1 and R2 of the rings. They have the resistive coating on their inner surfaces and are tightly fitted on the axle. So as the axle rotates, the rings also rotate along with them. But they are connected in such a way that arm AB is always connected to the R1 to ring 1 and CD is always connected to ring R2, and R1 is continuously brushing against the brush B1 and R2, the ring 2, is continuously brushing against the brush B2. Okay, now according to Fleming's right hand rule, we need to have for generators, we use the Fleming's right hand rule. Electric current is produced in the branch AB and CD in the direction. So when this coil is here upward, when the force on AB is upward, so the coil will rotate in a clockwise direction, pushing the ring AB upwards. So when the ring AB is upward and the direction of the magnetic field is along the index finger, you find the middle finger pointing inwards. So the current now in AB loop is going upwards, okay, in this direction, and in CD it is going downwards. As a result, the current now is going, say, A, B, C, D, okay, and then through this external circuit from B2 to B1. Right? Now, after half a turn, when AB reaches here, now the direction was this way, upwards. Now when AB reaches here and CD reaches here after the half turn, you will notice this arrow for AB, which was upwards, will now turn downwards. And the arrow which was downwards for CD, because CD is being pushed upwards now, so the current will go inwards. Initially in CD the current was outward, AB current was inwards. Right, but now the current in AB will become outward and the current in CD now will become inward. So here itself you know that the direction of current has changed. Initially in AB it was going upward. Now when AB comes to this position, down position, going downwards, being pushed downwards, the current will go outward. And at the same time, we also have to remember now that the rings have not changed their places. The rings are in the same place. Therefore, AB is always in contact with brush B1 and CD is always in contact with brush B2. Therefore, initially when the current is going upwards, the current is going in the direction of A, B, C, D, B to B1. Okay, but when this brush has come downwards, now the direction of AB current has moved. Okay, now the current will go from D, C, B, A, and because of that, now as the direction of current has changed, instead of going back this way, now the current will go from B1, now it will go this way, okay, from AB and then come, because the brushes have not changed their places, they are still in contact with the same armature, with the same arm. Therefore, now the current will reverse its direction and in external circuit, it will now flow from B1 to B2. When AB is up, it will go A, B, C, D, B2, B1. And when AB is down and CD is up, but the brushes are touching against the same ring, therefore the current will go from DCBA, but now from B1 to B2, because this has not changed, though AB has come in this place, but the ring has just rotated. The ring has gone down, okay, but along with it, the slip ring has also turned, making contact with the same B1, and therefore now the direction of current has reversed. So instead of going from B2 to B1, since AB has gone down, it will now go from B1 to B2. So for every half a turn, the current will go B2 to B1, B1 to B2. Again B2 to B1 when AB is up. When AB is down, it will go from B1 to B2. If we do not want the current to alternate, then we have to use split rings. Okay, that will turn into a DC generator, but we don't want a DC generator here. We are creating an AC generator. We want the current to be altered. Therefore, the current will now go in this direction for half a turn and in this direction for second half a turn. Okay, so after every half rotation, AB takes the place of CD and CD takes the position of AB, and therefore the induced current, instead of going to A, B, C, D, B2, B1, it will go to D, C, B, A, B1, B2. Okay, so that will be the direction of the induced current after every half a turn. Okay, now and this happens because BA is always in contact with brush 1. If you look in this picture here, they are tightly attached. AB is tightly attached to the same ring and the same brush. It is brushing against the same brush. So when it is up, okay, the direction will be different, this way to this way, and when it goes down, then the direction will become the other way, opposite way, this way to this way. Okay, that is from the other side. So hence the external circuit current flows, initially it flew from B2 to B1 and then it flows from B1 to B2. Thus for every half rotation, alternating current is produced. This is called as AC generator, and the current that comes to our homes is all AC current, alternating current. Okay, so this is how AC generator is constructed and how it works. So we have slip rings. Here you can see very clearly brush 1 is brushing against ring 1 and brush 2 is brushing against ring 2. And constantly it is in the same contact. So when the ring, this armature is going up and down. When it is up, the current will go this way, B2 to B1. When it is down, quickly the current will now go the opposite way. Look at the armature when it is down. Okay, so when that AB goes down, that immediately the current is reversed. So we had to show arrows. Initially we'll show it upward, and when it goes down, and here it will be downwards, but after half a turn this will show upward and this one will show a downward flow of electric current. So here we end the working and construction of an AC generator. Okay, and hope you have understood the entire concept. Take care. Bye-bye. Keep studying.